major who is happy-ish and successful-ish. And without further ado, for those of you that don't know me, hello, I'm Ali. I graduated in 2021 from Rutgers with a degree in computer science, creative writing, and philosophy. I'm currently a full-time software engineer at Microsoft, and I have some hobbies in general. I like infrastructure and web development on the tech side of things, and on the non-tech side of things, I like moral philosophy, all forms of creative writing, and tabletop role-playing games like Dungeons and Dragons. So while I was preparing this talk, the big question I was sort of asking myself, and the question that I hope to answer for you all throughout the course of this evening is, what information did I wish I personally had at the beginning of my computer science major? And I organized those thoughts into three sort of chapters. Chapter 1, questions to ask yourself while, preferably before pursuing a computer science degree. Number 2, some sage advice about how to be a computer science major and a happy person, or at least try. And 3, some good references for finding the type of applied computer science that's best for you. So real quick, just to start, something that a lot of people get wrong about computer science is that if you work in tech and pick up a computer and learn how to make it work, you will automatically be very wealthy. And I'm sad to tell you that that is not the case. Before sort of like doing a computer science degree, this is something you sort of have to like reconcile with yourself. Studying CS puts you in an industry that has a higher than average starting salary, but it doesn't necessarily mean that you specifically will receive one of those salaries. It's a very competitive industry. People start programming in like middle school these days. So the amount of work that it takes to be as competitive a candidate as not necessarily what's industry standard, but what we're seeing a lot of new grads sort of be capable of is a lot of work if you're new to tech. Also, tech jobs are difficult. And if you're desperately struggling with the concepts that you're taught in class and not really doing sort of like extracurricular work of learning what software engineering is, because the stuff that you do in class is not going to be the same as the stuff that you do at your job, you're going to struggle to get interviews. You're going to struggle during your interviews, and you're going to struggle to keep a job if you ever end up getting one. And I don't say this to discourage anyone, especially like underrepresented minorities, whether that's an racial minority or a gender minority, or people who come from low income backgrounds from sort of studying computer science. Like, it's really not my goal here, but I'm telling you this to sort of temper your expectations. You genuinely might be happier and more successful elsewhere. It's not like it's not beep boop bop 100K salary. There's a lot of work between you enrolling in 111 and making $100,000 a year. So that a fair warning. If you're early enough in your undergraduate career that switching majors is an option, I implore you to ask yourself, do I actually enjoy programming? Do I find the concepts in class sort of like interesting on an intellectual level? Does computer science intersect with another field that I'm passionate about? Maybe you're really into like public policy and like political science and stuff like that, and data science is the thing that is really interesting to you. And yeah, in that case, computer science is a thing that you should continue to study. Maybe you're interested in urban planning, and data insights for urban planning is really interesting. Maybe you're interested in like robotics and aerospace and so on and so forth. And there are those like intersections. But if the reason that you are studying computer science is because you were told that it would pay well, maybe look elsewhere. Another really important question that you should ask yourself is, am I horrified by the prospect of doing work that potentially hurts people? Am I a morally convicted enough person to educate myself about the negative externalities of working in tech and to either offset that harm with my salary and time, or to the best of my ability, minimize / reduce that harm at my job? It's no secret, I think, that in the last sort of like 4 or 5 years, we've gotten a much more intimate glimpse at how evil tech can be. Artificial intelligence is being trained to sort of like promote profits over people, which is really bad in the healthcare industry, for example, where an AI might set the price of a treatment, but that is for the profit of like the hospital and the insurance company. Facebook does bad things pretty consistently. A lot of tech companies work with ICE and like the US military industrial complex in general. Those are bad things. Are you willing to be a part of the solution if you work in this industry? And if your answer is no, stop studying computer science immediately. Drop off of the Zoom call, leave the cave, drop out of your classes, go go enroll in finance, transfer to RBS. So that way, when the revolution starts, we come for you first. Yeah, there's a lot of evil people that work in this industry, and a lot of people who are sort of like ambivalent about the moral like consequences of their actions that already work in this industry. We genuinely do not need more. Here's the way that I sort of think about things. Computers are a force of nature that touch almost every living person, but so few of us know how to bend them to our will and actually like make computers do stuff. In that vein, tech is kind of like magic, and computer scientists are like wizards. We spend a lot of time studying this thing that not that many people understand, to be able to like wield it to do the things that we want to do. And I can't imagine living in a world where the best use of a wizard's talent is to make money. So if that's why you're into it, just go do something else. In fact, the something else that you can do is just sell drugs. Like not even joking. It requires no formal education. You have flexible hours. It's legal in 18 states and decriminalized in 13 more. The product literally sells itself. Drug dealers are well liked and cool, and computer science majors don't know where to buy drugs. So there's a lot of you have some options, buddy. So yeah, if you want to do shitty things, just go sell drugs. It's not a shitty thing. You know what I mean? Like if you just want a job where you do something, make money and leave, there you go. This is the job for you. For everyone else though, how to make studying computer science more bearable. Here are a few things that I did that personally worked for me. I pursued minors and joined student orgs and other activities outside of computer science. I think that having a good sort of like balance of that is really, really, really important. I have a fun story about one time in my freshman year when I was taking data structures and really struggling with one of the projects. I had to go to one of my creative writing classes for like attendance because the attendance policy for that class was really strict. And I was very, very upset that my data structures project wasn't working or whatever. I had a huge scowl on my face, and like to the point that it scared off another one of my classmates who was also walking to class, who was like approaching me to say hello. And then by the time that I left that class, I had felt like significantly better about my day. And I was like, you know what, this will be fine. Things are going to be okay, even if computer science is difficult. Number two is form and find communities of computer science majors so that you're not doing it alone. This is very, very important. Without a lot of my friends and like resources and communities in the CS department, I feel like I might have like fallen off the wagon a lot earlier than I ended up actually falling off the wagon, which is not at all because I'm still here. And number three, try and develop an appreciation for the thing that you're dedicating 20 plus hours to a week. By a sort of like head count, how many people in the room are like freshmen, juniors, sophomores? Like either drop it in the chat, or Max, if you want to like count out who's what in the room.
I'm a senior. Oh, okay. I guess we got 6 friends.
Cool. Well, I'm seeing in the chat lots of sophomores and freshmen. Ooh, fun. Cool. I'm going to assume I see the only person that I see in the room right now, like on over the video chat, is Saurav. I know that Saurav's a junior. Oh, thank you, buddy. That was very polite. But yeah, cool. Y'all are very much early enough in your career that like these tips are actually useful and not just like, well, good luck. But yeah, I'm like I said, I minored in creative writing and philosophy, was on the board for the Muslim Public Relations Council, attended poetry open mics on campus. I became deeply immersed in the Rutgers CS community, which helped me get internships via referrals, but more importantly, it gave me friends to take notes from, to get notes from if I ever like missed class, review concepts with, and most importantly, take breaks with. There have been like, I think if you are a sophomore, I think by this point you've probably had that like, shit, the project is due at 11:59. Me and a bunch of my friends are all sitting in like a triangle or a circle with our laptops all sort of facing each other, trying to get this thing in. What are we gonna do? That's a very, very valuable experience. If you haven't had that yet, I highly recommend it. And then like to the third point of like developing an appreciation, think at a certain point, specifically between 112 and like 211, between data structures and comparc, you sort of understand like how the concepts fold into each other, and you end up developing like an understanding of how computers actually work and how that data is organized and so on and so forth. And that like little spark of like, oh shit, it clicks, I get it, is really, really important. And I implore you, if you've had it, to just keep chasing that feeling. And if you haven't had it yet, to sort of like try and like outside of class, just think about how these things like sort of fit together. For me in CompArc, when we were learning about like the sort of like text data BSS stack thing, and then we got to like the stack and the heap, I was like, oh, this data is organized in this way, which I understand from taking data structures, because this is the best way to organize said data, and so on and so forth. And if you end up taking like systems and operating systems and distributed systems, you see those concepts fold into each other more and more. And it like, again, it's about like building this understanding and then subsequently an appreciation for like this thing that you do that is very difficult, that you should be proud of yourself for doing. For me personally, I also worked on a lot of side projects. The stuff that you do in class is usually really boring and like not a useful, valuable skill for your industry. Every single computer science student in every computer science department in the United States more or less gets the same projects for the same classes. So like you're like, I don't know, all of the data structures projects have changed, so I can't like really reference them. But like, for example, like Cache Simulator in CompArc, for anyone who's taken CompArc, right? Other people have built that. And even though that was one of my favorite projects, like it wasn't as rewarding as say building Bush Web Services, which is an app hosting platform on RU Wireless Secure for CS students that runs out of the hackerspace about like 10 or 20 feet down from those of you who are physically in the cave, right? Like in the downward direction. I also worked on some mutual aid stuff with web development, and I used JavaScript to build a Dungeons and Dragons character creation app, right? And that was stuff that was all fun and cool. And again, like really, really helped me stay in the major and enjoy it, because I was like, oh, this pattern that I learned in this algorithms class or this like whatever class helped me like actually take those skills and put them into something that sure like ended up going on my resume, but more importantly like went in and came out of my mind, which is effectively what you're going to be doing at a job. So if you haven't worked on a side project before, I highly recommend it. You can get started with really simple stuff and learn a lot in that process, and more importantly learn to enjoy it, because you're doing it for fun and not a grade. This brings us to the third part of the talk, which is sort of helpful technical information. This is going to be the longest part of the talk. We're going to be going through a brief explanation of how all technology works, B, a deeper delve into how web-based technology works, and C, which areas of interest in computer science correspond to or map to which skills, and what courses teach those skills. So this is going to be good information, hopefully. So just a quick disclaimer, the computer science major, specifically at Rutgers, isn't a skills development program. Honestly, oftentimes the things that you're going to be interested in with regards to tech, whether that be like machine learning, blockchain, UX, UI design, etc., are all skills that you're going to have to pursue on your own. Your coursework is specifically focused mainly on making sure that you understand the skills that it takes to build the tools that you need to teach yourself, and how to think about writing code in general so that you can do it at any level. Fun fact, the reason that I know this is because one time I talked to Professor John Austin Francisco, who's the curriculum chair for the CS department, about getting some classes that like teach kids React and Flask and things like that. And he close to verbatim told me this. So yeah, if you want to learn shit, join clubs or put in time on your own. But the classes are good as like an introduction to these concepts and ideas. So generally speaking, the way that all code works is that there's four components, right? There's a front end, a back end, a data store, and a system, right? So the front end is what the user sees or touches. That could be a website, it could be a mobile app, it could be a command line interface like your terminal, be a tool in your terminal. Sometimes your front end is literally just other code, which is how like APIs work and so on and so forth. But the point is, the front end is what the user sees and touches. The back end is what you show the user, right? So the back end gets information from your data store and returns it in a very specific way. So here's an example. When you are on Instagram or Twitter or whatever, right? You are implicitly sort of requesting like tweets or photos from people that I follow on Twitter/Instagram, right? So what the backend does is it goes into the data store and then like puts filters on the data already in there, right? So it'll be, give me all data that includes the following people, right, that come from the following people in the last hour. So when you log in, your like feed shows you the things that you're interested in and not just everything that's ever being posted like all the time, right? Your data store is all the information a user might want. So like I said, for Facebook, that's going to be like posts, friend lists, so on and so forth, right? But your data store might not be like a traditional database, right? You could be reading files on the system. You could be just tapping into information, like you could be getting data from another sort of source, right? So your data store could be an API that you're just transforming the data and filtering it down and restructuring it for the front end, right? But in general, the data store is all the information that a user might want. And the system is how the above three are possible. It's like all of the sort of like processes and threads and so on and so forth that make like a front end, back end, and data store possible. So for web code, it gets a little bit more granular. For all web-based applications, including mobile apps, your data is probably going to look something like this. The very top level, it's going to be graphic design, so how something looks. The easiest way to describe this is like the reason that on Instagram your stories are like a circle as opposed to a square or a piece of text, right? It's the sort of like graphical design of how to like, it's a graphical design of the thing that is like the little bit of like art aspect that allows you to have an engaging user product, right? Number two is going to be UI design, which is how something is laid out. So again, this is like a little bit more on like the artsy side. So why is my whatever, why are my stories at the top, and why do they like go out in a sidebar that I have to scroll through this way as opposed to being like vertical? Why are Instagram photos proportioned the way that they are proportioned, and so on and so forth? What data goes where? That sort of thing. Your front end is going to be how user behavior maps to data requests. And this is usually written in React or React Native or like Swift or Kotlin or whatever. So same deal of when you click on an Instagram story, that tells your front end to ask your back end for like the links to the videos that they are going to show you, right? Like all of this stuff is written in a very like templated way. And the only thing that changes between you clicking an Instagram story and seeing one person's video or photo versus another person's video or photo is literally just the URL that is being served to you in that template. And that is what the front end is for. Your API dev is the next layer, which is data retrieval and formatting, which I kind of got to in the last slide of I'm going to ask my data store for this, and I'm going to return it in this specific way so that my front end knows what to do with it. Number five is your database, which is your data store. It's usually done in some sort of SQL or NoSQL database like MongoDB or Firebase. Pretty self-explanatory. Number six is your infrastructure, which is how reliably code runs on a system. If you've heard of like virtual machines or like containers through Docker or something like that, it's sort of that. But in general, infrastructure development is usually just, hey, if my server goes down, if the resource that I am writing goes down, how much work is it going to be to spin it up again, right? So if you containerize your applications with Docker, then it's just as simple as running Docker start in your terminal, right? Or Docker run in your terminal, right? If you're using a VM, that'll have different like implications, but also different benefits and like pros and cons. You know what I mean? And then finally, number seven is systems dev, which is what is like possible with a computer. So how do you communicate information over a network between two computers? How do you like what processes are currently running on my computer? What processes can run on my computer? What threads? How do I like multi-thread an application, right? So that it does multiple things at the same time, and so on and so forth. And this is literally how all applications that run on a server that you have to like access through some kind of client work, right? So for a front-end engineer, you're mostly concerned with the first three, right? Graphic design, UI design, and front-end dev, right? Of how does it look? How is my data slash like content structured on the page? And then number three, when the user, like what user behaviors, right? So like if I like a Facebook post, what does that change, right? Like what do I have to, what network request do I have to make, right? Probably you're going to make an API call to your server to update the record of who has liked this post and how many people have liked this post, right? And if you're interested in front-end development, I know that the ITI department does a lot of courses in it. The computer science department does absolutely zero. There are a lot of really great YouTube tutorials on like learning Flask and learning HTML and CSS and a lot of the different like UI frameworks like Bootstrap or Material UI or Tailwind or whatever. And I think that some of the clubs also do that here. So look at Blueprint or CreativeX. If you're interested in backend engineering, it's usually concerned with the middle block. So API dev and database, literally just how do I set up a database? How do I set up an API that can get information from a database? And then how do I set up like the different routes for the different kinds of data, right? So in my opinion, backend engineering / backend development is the easiest thing to learn, and it's the most versatile thing to learn, just because once you've built one backend API, or if you've even used a backend API, you've kind of built and used them all. It's the same fundamental principle of if I hit this endpoint, then it returns this data in this format, right? And once you've done that, like this is probably what you're going to be doing at your job when you graduate or at your internship over the summer. This is what most of your side projects are going to start with, because building something that looks really good but doesn't do anything isn't super valuable, and so on and so forth. So the specific class that's like useful for this is CS 336, which I think is called Principles of Information and Data Management, but everyone just calls it databases because that's what the class is. And it'll teach you how to build, how to set up and build a SQL DB and an API to get that data. But again, it's not that difficult to learn. So if you look at YouTube tutorials and just how to set up simple REST API, you'll be able to learn this concept relatively quickly. The languages that are super popular for backend as well are JavaScript and Python, which are, I think, the two easiest languages to sort of pick up and learn. So check out backend engineering if that sounds interesting to you, or if you're sort of just getting started. Number 3 on my sort of list is data science / visualization. So data science at its core is about taking raw information and making it mean something or say something. So obviously that's going to require some API development of, I have this data store with like gigabytes of data, right? Like millions of entries or maybe thousands of entries or whatever, right? How do I select and transform that large data store into a thing that means something, right? So if I'm looking at traffic data, probably I need to build an API that looks at the times of different traffic incidents and like how many cars are on the road and what kind of cars get into the most accidents, right? And then from there, you're going to want to learn some like front end skills generally, whether that's graphic design, UI design, and front end dev, probably all of them, to be able to like appropriately and accurately visualize that data to communicate the point that you want to communicate. Some classes that teach like sort of the fundamentals of data science are CS 142, CS 210, which I think is a new class that I was told to include on this slide, and CS 439, which is Intro to Data Science. I think that these classes are really cool, and they'll teach you sort of like the fundamental algorithms of how data science works. In terms of like tools, I took the graduate version of 439. I think it was called, the version that I took was called Massive Data Storage and Retrieval. 439 is just Intro to Data Science. So I ended up learning about Apache Spark, and I got to get started with like Jupyter notebooks, which are valuable tools. The one thing of note, if you're interested in data science and you're also interested in graduating on time / don't have that much space in your schedule, 142 doesn't count for elective credit, but I think the people that I know that have taken it have gotten a lot out of it and have learned R through it, which is pretty cool. I think it's a more powerful like data science language than some of the other ones. So yeah, definitely check those out, but something to keep in mind. And then finally, we get to like DevOps / production engineering. DevOps and PE positions make sure that the company's code runs 24/7, which means in some capacity writing code all over the stack, but fundamentally you're sort of in the bottom 2, right, of infrastructure, like how do I package my code and how does it run on the system, and number 7, like what can be done with the system, right? So again, like thinking about like Facebook.com, right? They hire a bunch of people, like hundreds of people to solely work on making sure that facebook.com is never down, right? That means that they probably have a lot of monitoring tools for their infrastructure, right? So that's going to include some API development where instead of hitting a database, you're hitting like files, right? And you're like looking at the process ledger of what's running on your computer. And if something changes, then you're gonna fire off some command to the system to restart that process, right? Maybe you want to, what's it called, right? Like maybe you want to be able to just click a button, right? And restart a service, right? That's going to require some amount of front-end development. Maybe you want to be able to like visualize and track the performance of your system. That's also going to require some front-end development, right? So PE is pretty cool, and you like really get to like the core of how computers work through this. It is also kind of a boring job, not gonna lie. A lot of people who sort of like went to Rutgers recently went to Rutgers during a period of time where like PE was like a big craze. And then they graduated and got PE positions. Were like, damn, this shit kind of sucks. So before you like go off and apply to PE positions, strongly recommend you read about it. But if this like sounds interesting to you, of how does code run? How do I make sure code runs all the time? How do I make sure it runs reliably? How do I get insight as to how my code is running? CS 214, systems, CS 342, information technology, and then 416 operating systems, 417 distributed systems will teach you about this job indirectly. The reason that I say that it'll teach you about this job indirectly is because it'll teach you about how each of these things works on a computer. And then in your own mind, as you're taking the class, you'll be like, oh shit. So when something is not responding and I restart it, I'm literally restarting a process on my computer, right? And then when you get to the output to OS, you'll be like, oh, the scheduler is a thing, and what runs in what order is scheduled by my computer. And then when you get to distributed, you're like, oh, all of these computers talk to each other. How do I like that? That's how servers work, presumably. And they're interesting classes. So recommend those as well. For people who are interested in machine learning and artificial intelligence, that doesn't fit into this diagram nearly as well as like the other disciplines, but once you've trained your model, it'll probably live in the backend as an API. Personally, I don't super find in ML/AI enjoyable or like useful for society, but if you do, you can take CS 425, which is brain inspired computing, which I've heard is a very fun, very interesting, although difficult class. And then there's like intro to AI, and then some seminar in AI, and then there's a bunch of classes. Those are the course codes. Go write them down and look at them if you're interested. Okay. So that was a lot of information that was just thrown at you. I don't know if you like you're probably thinking at this point, am I expected to remember this and internalize it and know it for the rest of my life? Probably not. Obviously, there are areas of interest that don't explicitly fit in this paradigm. So like computer security is like a great example of something that you can't just like boil down to like like a box drawn around like a certain number of steps, because security exists at all points, right? It could be as far down as like the system of exploiting heap buffer overflows, but it could be as simple as my like the connection between my front end and my back end are not nearly as secure as they need to be, right? But in general, most code follows this front end back end data store system model. And if you're able to sort of recognize that pattern as you are either teaching yourself a new skill or in class, I think that you'll get a lot out of it. And then also, because now you understand that this is how all code is written, it's really easy to lose track of what you're actually learning in like 111, 112, and 211. And good news, now you know everything that you're learning about until maybe like your sophomore spring semester is going to be exclusively about the system and how it works. Data structures is the math of the system. CompArc is sort of the logistics of the system. And 111 is just the base fundamental skills you need to be able to interact with it at all. This way of organizing these ideas is so that you don't lose track of what you're learning, and so that when the time comes for you to think about what you want to do with your computer science degree, you know where to start, especially if there are things that you like outside of CS that interest you, that you'd like to have a technical career in, right? So like I said, like data science and data insights, huge, very important, right? Like if you want to work in any sort of like political science or urban, like any kind of public policy position, right? Whether that's healthcare, like education, like actual like legislation, right? All of like data science is probably what you're going to be doing in that capacity. So you know to focus on your front end and back end skills, right? If you're interested in robotics, you're explicitly interested in sort of like the bottom, right? Like the like number 7, like the system dev, because you want to tell like you're basically just saying, hey, computer, do this, write this set of bytes to this file that controls this motor, right? And so on and so forth. So hopefully that was helpful. I'll answer any questions y'all have in the end. So some great resources to get started in learning about all of these different concepts outside of class. If you're interested in sort of like quick YouTube videos and tutorials and stuff like that, a channel that I personally really like is called on YouTube is called Fireship. They do like X topic in 100 seconds. So it's a very, very like comprehensive overview that is less than 2 minutes long. That like is a great introduction to different topics. If you're interested in more like long form of like, I specifically want to learn this skill and I want to get really good at it, I really recommend looking at courses on Udemy. They go on sale all the time. So you might be able to grab like a free course, but even then, like sometimes like $100 courses will go on sale to be only like $20 or $10 or something like that. Sometimes they get into like single digits. I have a course on React that like I live and die by. That is the only reason that I know how to write React JS, and is like the thing, which is the thing that I do at my job. Like at Microsoft, I'm writing a lot of sort of like front end code right now because I work on a VS Code extension. So like Udemy, very helpful. I have another course on like Docker that is like highly intensive and like sort of gets into Kubernetes and orchestration in addition to just like how to set up a Docker container and how to run programs in Docker. And if you're looking for a more sort of like sustained community is really important. I don't know if Rahul is in the room right now, but if you're sort of like getting started and want someone to like help guide you, talk to Rahul. He's a nice boy. But in general, go to like the hackerspace and the cave and like find those people who you're sort of gonna like learn with and grow with inside of the major. Finally, I have some inspiration for you. So the pudding.cool is a data visualization publication, often about pop culture. If you're interested in sort of seeing like what is possible with data science, strongly recommend checking out the pudding. They did like a data visualization at one point about like Spotify or something like that. Like, oh, I'm trying to remember what it was. Yeah. So someone wrote a machine learning algorithm that bullies you based on what your like like most listened Spotify music is. And the way that it did that was sort of like by pattern matching what people tweet about who listen to specific kinds of music, right? So it was pretty good. I got sufficiently roasted by it, but there's a bunch of really great articles on there. I think they have some stuff about the NBA. I think they have some stuff about like TV. So strongly recommend checking out the pudding. And Product Hunt is a platform where startups and independent programmers can post software that they've built. So if you're interested in sort of just like seeing what is out there and what is possible, scrolling through Product Hunt is very fun. So that brings us to the end of this presentation. Some closing remarks. At the beginning of this talk, I spoke very strongly about intention. If I came off as like harsh or exclusionary, I want to apologize. Like if the first part of this talk where I was like, hey, if you were only studying CS to make money, don't do that, go sell drugs, made you feel bad, I am sorry. But computer science is unfortunately a field that requires really good intention setting when you enter it, especially if you want to succeed and feel fulfilled by the work. I know a lot of people who like only wanted to study CS for the money. And because of that, they like anytime they weren't doing well in class, they felt like they were fucking their life up and resorted to like hostile tactics like bullying and aggression and like emotional manipulation to be able to like graduate. Like the cave pre-COVID was a very, very stressful place. It was a very interesting time. And I don't want people to have to go through that, like on either end of it. I don't want you to feel the need to emotionally manipulate someone to pass their classes. And I don't want you to be someone that gets emotionally manipulated. So like, if you're really stressed out about this, like just go do something else. Go do something that you really enjoy. Like maybe you'll make less money, but you'll be a happier person. Like statistics show that like the amount of happiness that you get per dollar earned in your income goes like significantly down after $70,000 a year. And there's a lot of industries that pay 70K. So yeah, I hope that after this talk, you feel more prepared to pursue your degrees and find a love for computing that allows you to do things that most people can barely dream of. Again, like everyone uses computers, very few people know how to like make the computer do something. So that like there's a lot of like opportunity to like play there, right? There's a lot of opportunity to find fun in that work. And I hope that this talk has gotten you closer to that. I am rooting for all of you, and I can't wait to see what y'all do throughout college and afterwards. PS, please join Ethetech, which is another club at Rutgers, and learn how to be a not evil technologist. I wasn't joking about how many shitty people there are in this industry. If you attended this talk and I find out that at some point you become like a billionaire or like work on something egregiously shitty in the tech industry, I will find you and beat you up. So join Ethetech to avoid that end. And for everyone else, this talk is very, very long. So I sort of minified it down to like a document that you can revisit if you go to that link. So yeah, feel free to go to that link. If any, I sort of want to like wrap up and get to Q&A because it's 3:42 where I'm at and I'm technically working right now. So I was joking, that's my Twitter. Go follow me on Twitter. I will send Maxwell the link to the slides so that y'all can revisit this though. And with that, I am done. Thank you for your time. Does anyone have any questions?
If there's any questions in chat.
I cannot hear anything, I will say, from the room. So if there are questions, just send them in the chat.
The screen isn't on, but you can ask. Like they can hear you.
Oh, I'll do that.
Yeah.
So my question is that since you did philosophy as a minor, I just wanted to say like, or ask, do you have A, either course recommendations, or B, any like stories or experiences with like the two combined, comp sci and philosophy?
Oh, in philosophy, yeah, of course, recommendations. There were two specific classes that I took that were very valuable. One of which was Minds, Machines, and Persons, which is cross-listed with computer science. So if you take Minds, Machines, and Persons, that counts for CS elective credit. And Minds, Machines, and Persons was really interesting because the whole point is like, hey, what is a person and can computers at some point eventually become people, right? And you sort of like explore both of those topics really, really in depth. And I think a lot of my resentment for artificial intelligence like comes from the fact that I ended up taking that class and like learning a lot about it. And then the other class that I took that I really enjoyed was philosophical ideas in science fiction. So that class is literally just, hey, time travel, is that possible? Robots, are robots people? That was like some overlap in that class. But yeah, I strongly recommend that all CS majors take like at least one philosophy class, because I think like the way that I understand philosophy, and I think just generally what the goal of philosophy is we should be able to like formulate ideas and communicate them effectively, right? And those ideas generally tend to be about the real world. So I think even if you take like a vanilla ethics class, you immediately start applying like those frameworks for thinking into technology, right? And you start being able to like see, oh, like there, like in the past, people believed that there needed to be like some minimum amount of suffering, because if there wasn't, then like society would collapse, right? Like if you think about utilitarianism, like if people aren't like being downtrodden by their jobs, then like there's literally just nothing, right? Like nothing exists, nothing happens. But now we have robots that can do really simple, really rote tasks really effectively, right? So like computers can be a fix for artificial intelligence. But what if computers feel pain, right? So yeah, that's like my general experience. I also participated in a fellowship called the Impact Fellowship, and like am now a program manager for the organization that hosted that fellowship, Impact Labs. And there's been a lot of fun conversations about like how tech and ethics intersect there. But yeah, like if you're interested in science and philosophy, it's a very valuable combination, because it probably, not like prescriptively, but on average, people who study CS and philosophy tend to care more about like ethics and human rights than people who don't, who like get into the industry for tech. So, or just for money, or even if they just like tech. So thank you for having that interest, and please go take a class. Are there any other questions?
Nothing like that.
Okay.